welcome to this month's working group meeting. Um, we have basically 2 points on the agenda. I think you got the email, don't need to share it right now. First point would be David, so it's like everyone that's involved with behavior trees is supposed to be called David or something like that. No, but uh, we have met at I think a ROS meetup that the FZI, which is in Karlsruhe, also in Baden-Württemberg, in the state where Bosch is as well, in Germany. And FZI is a applied research institute, and they have made a very nice um, behavior tree runtime. Nice in the sense that it is different to the one that exists right now, and it is Python and can be changed at runtime. That's at least what got me interested. And yeah, and I would now give the word to David. After this, we will have a bit of a discussion about this workshop idea I had, but yeah, let's talk about this afterwards. Thank you very much for agreeing to present to us, David.
Yeah, so it was actually not a meetup. It was the ROSCon in Karlsruhe, the German ROSCon.
This also happened, yeah.
Yeah, which is actually, incidentally, the same presentation I will be using now is the one that I held there, but I'm not going to do it in its entirety. Mostly because the slides are in German, which is obviously a little bit unfortunate, but I only want the graphics, so it should be fine because I want to do this a little bit more as a live demonstration than a full-on presentation. But yeah, we developed, actually we started a while ago, this behavior tree framework that we call ROS-PT-Py. It was initially built for ROS1, and the idea or our motivation was that we usually work with robot teams and wanted to have a rather observable high-level state machine for these teams. But we also, because we did a lot of demonstrations and not that much product work, we wanted it to be relatively flexible in its editing capabilities, so we can quickly change things around if we feel like we need a new behavior here or a slightly different sequence of nodes at a different point. So these were the two main design constraints that we had. And I think I can skip a lot of the motivation part. You all should know that, what a behavior tree is and how it works. But these are basically the main selling points. We wanted it to be in Python, so we can have live reloading of nodes and declare nodes or new nodes without having to stop the behavior tree instance and, for example, recompile, just load them in. We have a web-based editor, which is where you can observe the tree and also edit it. It is completely open source, both the ROS1 and the ROS2 version, but we have to say that the ROS1 version is definitely the more feature-rich one. The ROS2 version is still in its startup period. Basically, we are constantly trying to improve it as we have switched to, I think, only ROS2 by now for most of our projects. So we have a lot of interest in pushing this further. But in general, when you have a look at kind of behavior trees and what most libraries currently offer, per default, most of them have some sort of reactive behavior definition. And especially the ones that are built for robotics have a lot of nice additions to support work in robotics, like these long-running tasks, like the ability to parameterize certain nodes to make them reusable, subtrees where you can kind of encapsulate behavior and reuse it, and also things like the shared blackboard that, for example, behavior tree CPP uses. And we've built atop this and added a few new features that we haven't seen thus far, namely data connections between nodes in our framework are managed through a data graph. So you must explicitly, once a node, for example, finds something or produces some sort of output, you must explicitly, through a edge in the data graph, model how this is passed on to other nodes and to which other nodes it's passed on, which also allows us to kind of guarantee that nodes are never ticked with invalid inputs or missing inputs, because we can detect it before the node is even running. The second nice feature, or the second set of features that I've kind of highlighted here, are mostly concerned with our work in multi-robot systems. So we do have the ability to calculate a utility value for a given robot for a tree or a subtree, and then execute it remotely on another robot running the behavior tree framework. So we can just serialize the nodes, send them over, and the other robot can execute this task. And there's something that we're currently actually researching on, and that is presented at ICRA this year, is a kind of similar interface that allows for remote execution of subtrees, but basically on a skill level. So each robot can declare a set of skills or capabilities that it provides, and then we can find a runtime assignment for these skills on the different robots, and then kind of execute the behavior trees remotely. Now, as you all are kind of developers, and this is more on a developer perspective, especially Rust developers, here's another like overview slide of what the most important points from a developer's perspective are in my eyes, which is, first of all, that the nodes are in Python and they're really easy to write. So what you can see in the graphic here is the annotation that we use to define a class as a node. And you can give it a lot of like meta information about its inputs, its outputs, its options, how many children are allowed. And all of this is then immediately, for example, rendered in the web GUI, or can be used then later in the node, for example, to set output or input fields. And this is like a very concise syntax that allows you to quickly write new nodes without having to do any weird like meta programming or things like that. Yeah, as I said, we have this kind of live web editor where you can just edit the trees and then immediately run them without the need to kind of save or compile or anything. And we can hot reload them and update the actual code for all of the nodes at runtime, because we use Python. And because we're all doing everything in ROS, this is highly integrated with ROS. So for example, if you want to do a publisher or a subscriber in ROS, you can just create a kind of templated topic subscriber node, and then it will show you all of the ROS messages that you have currently loaded in your workspace, and you can just in the web editor type out which node this topic is or which type this topic has, and it will immediately kind of update all the inputs and outputs according to your suggestion here. And this works with all the ROS messages that you currently have loaded, which is really, really nice when you try to actually develop something. We can also do like a remote development light. So if you have multiple robots in the same ROS domain or connected to the same ROS core, depending on your ROS version, you can, from the web GUI, just edit the behavior tree, or the behavior trees running on each of the robots in the domain. So you can just basically have one laptop, for example, for editing the behavior trees on an entire team of robots without the need to kind of SSH on the robot and then do something there. And lastly, because all of this is implemented in ROS, we also have, or the web GUI also uses services to interact with the behavior tree. So if you don't like our GUI, you can just write your own one and just interact with the ROS interface, basically. Now to kind of compare it to the biggest other contender, which is behavior tree CPP, I would say that, or as you can see, we have a lot of similar features. We have some things that are supported in our version that are not supported in behavior tree CPP, mostly due to us using Python and kind of doing this online development thing. But the biggest downturn or biggest problem that we've kind of noticed with ROS-PT-Pi is that it's significantly slower. We only support tick rates of around 10 Hertz, which is fine if you want to kind of coordinate a large group of robots. But if you want to, for example, do a control loop or something like that, that's not probably not the framework for you. Yeah, we're not going to do this little scenario for our presentation. I'm going to share with you a kind of live, little live demo where I have our web GUI here, and I've loaded already a behavior tree, which is used to kind of call this action here, which moves a simulated UR robot to a specific end effector pose. So this is a custom message that I've defined in my workspace, which takes a pose stand basically, and a frame, like a TF frame, in which the end effector is should be located, and then calls this service here, or this action server, which is a move it instance that can move the robot. So you see the typical behavior tree things that most of the frameworks have. You have sequences or sequence of memory, and then you also have some constant nodes here, for example, that are all, for example, this here puts out the frame that is used later on in this action. And you can see here the typing system that we have, where you have this kind of output here that is of type string. And you need to specifically tell it that this should be a string. And this also kind of changes the editing options you have here. So if I add another constant node, you can see that I can set basically arbitrary types here, regular Python types like a dictionary or a list, but also ROS messages, like, for example, a geometry pose, which then has all of the data types that are present in a pose message that you can just set here and then use in your behavior tree at some point. And yeah, basically we can just start this, run this, and move the robot without any issues. So you can't see it at the moment, but for me the robot is actually moving, and now the whole behavior tree has succeeded. Yeah, basically this is kind of the general user interface that we have, and because we are, as I said, we have these strong introspection measures, we can also do things like, if I want to now call it a ROS service, I could just add a service node and set the service type. So for example, I said bool request, or I said bool service, and I could just click here. This would probably be called something like test. And this will adapt the input and output types. Should adapt them. Oh, is it? The tree is still running. That's why it's not doing anything. But basically, you can just set types here, and they will instantly update. And you can now just call any set bool service that you have in your system without the need to write an actual new node. And this works for any message that you might have in your ROS workspace. Yeah, other than that, because this is the ROS 2 version, it still doesn't have many of the nice multi-robot features, but we're actively working on creating that. So yeah, this was like a very short run-up of ROS-PT-Pi, but I imagine you have some questions maybe. So I would now be happy to answer them. Yeah. Yeah, Michel?
Hi, yeah, that was really nice. Looking forward to try it. I guess those connection from one node to another one was where basically the input outputs from
Oh,
basically to implement the infra-node communication, right?
yeah,
Yeah.
I can. Yeah, I
Yeah, if you
show
can
it again.
share the screen, yeah, that would be great.
Yeah.
Thank you.
I just so I'm just going to load a tree and then yeah. So these are the kind of the data graph I mentioned before,
Okay.
where you have the like the outputs are always on the right and the inputs are on the left
Okay.
side of a node.
Okay. So you do have a way to communicate between nodes, since you had
Yeah.
that table that you were comparing with the other library, with the BT.cpp library,
Mm.
and basically you had that red X on not Blackboard. I will write just for me for how you sell your point. Just I will write an asterisk, say we do have another way to do inter-node communication.
Yeah.
Right? Okay.
Yeah, we
I
had
have a
the
question. So,
yeah.
no, please go ahead.
Yeah, no, I just wanted to quickly say, yeah, we had the, I think it was not that visible, but we had the, okay, we have a data graph instead of the
Okay.
Blackboard, because we like the idea more that you need to explicitly tell like which node should communicate with which, instead of having this magical thing that might contain data or might not.
Okay.
Yeah.
Yeah, and okay. Now let's go to so my point, my question is, I don't know if you say it, but since one of your one of the strength is this online editing of the node, I was wondering if when you load when you have this hot load, you also constrain the same, that the node needs to have the same ports of the same type.
Kind of. It will, if you change the input and output configuration of a node, it would basically disconnect all connections that it cannot adapt at the moment.
Okay.
So you just need to reconnect them. So this might make your tree, like if you have a newer version of a node loaded that might have different inputs, this could potentially, when you load a tree, leave you with an invalid tree because some inputs and outputs are disconnected.
Okay.
In the ROS1 version, we have this concept called migrations that basically allow you to write in a somewhat meta Python code format how you could migrate a node to a newer version to overcome these challenges. So for example, telling it, okay, we just renamed this output or retyped this output, maybe add a conversion node in between or something like that. But that is not yet ported to ROS2.
Okay. No, that was just my okay, then that was just my doubt. Thank you.
Maybe also with respect to the data graph, I don't know if I understood you correctly, but you mentioned that you also check kind of whether the data is available. Because I mean, for example, if you would imagine this left control node would be a fallback node, then you could not be sure whether all of these children are executed, right? And then maybe one of these gray data points may not be available later in this, what's it, field to message node. Do you also verify that?
No, we want to, but we haven't done that yet. At the moment, the verification is kind of constrained to, okay, there are no nodes that have unset inputs. So what that means is that none of these inputs here don't have any producer basically that could feed them data. But we don't at the moment check that there is actually a valid sequence of nodes, or that every sequence of nodes actually produces valid data at this point. And this is then checked at runtime. So if at runtime there is no data here, the node will fail, and we will just treat that as if the node had any kind of internal error, basically.
Okay, because I think there's a paper on that. There, I don't know, if you don't know it, I can send it to you. There's a paper that they verified this data connections in a similar model.
That would actually be very nice. Yeah.
Maybe the other question would be, you say, how can you change a node at runtime? So where in your demo you had a problem that it was running right now and you couldn't edit it then. Is
Yeah.
there a way to kind
No,
of replace a running tree, or how exactly would it work?
no, you have to, like, you can't change the tree while the tree itself is currently executing something. That would just create a lot of failure states.
Yeah.
But what you can do is you can, what I mean with the hot reloading is that you don't need to actually stop the node and restart it. You can keep your existing tree, you can keep everything as it is, and then basically just add new stuff in there and start it up again, basically. So there's no need to kind of recompile or anything like that, or restart in this sense. But you can't change a running node tree in the sense of it's actually currently executing some of the nodes. That would probably create a lot of problems.
And when you use this as in your, I assume you use it in your projects as well, this tool. Do you then, do you usually kind of have, are your projects dynamic in the sense that you always kind of edit these trees, or do you also have a different mode where you kind of can save the tree and then just execute an existing tree without the GUI and so on?
The GUI is, I mean, when you start up the node, you can decide if you want to start the GUI with it. At the moment, we have or what we usually do in our projects is that we have these long cycles of continuously improving the trees, and then once we have a finished product, we usually just load the tree via a ROS service, just a startup script or something, and then start executing from there without having to without having to start the GUI at all. But what you can technically also do is there is a launch option to specify a tree or a tree path, a tree URL, and then it can just automatically start that tree once the behavior tree ROS node has loaded up. So these are the two options that we have. And I mean, you can load these trees from ROS packages, so that is something that is supported. So I don't have any trees currently in any package, I think. Because usually what we do, we have then a behaviors ROS package in which the nodes and all the trees live that are used for the project, and that usually contains a launch file that just extends the launchpad for the behavior tree node, and then just loads one of the trees from this package and runs it.
Okay. And in what is the file format of these trees? How you would specify them?
They are saved in a YAML file. I mean, I can show that also real quick. So they are stored in a, so in this case, for example, this UR movement tree that I shown before, this would be stored in a YAML file format that it basically is our serialized ROS messages, because we can send all of these informations at the trees through or over the network. We basically just serialize our ROS messages into YAML files and use that to store our trees.
Okay. And so you basically give the node a unique name, and then you specify the adjacent or the children per node.
Yeah. And I mean, most of the information here, like for example, for a node, mostly its child name or children are important, and the data connections, which are specified a little bit lower. But for example, this version and the is basically just used for the version checking aspect of it. But this max children, for example, this is just ignored because we take the version from the Python file that is loaded in the behavior tree instance. So there is some duplication here. It's not the most efficient saving method, probably, but.
Okay. Yeah, because I mean, this was also like an idea that I think is quite obvious, is that you would have like a way of interchanging the behavior trees between your tool and behavior tree.cpp, and then, as you said, maybe in production it's more useful to run the C++ library. But of course, this would mean that all the internal workings of the control nodes and everything is at least similar, ideally identical, and that's probably hard to guarantee.
Yeah, but I think it would be a very nice thing, because the ROSBT Pi is especially strong, in my opinion, if you want to actually edit a tree and have this use case of working on it like quite often, iterating over the tree quite often, rebuilding things, rebuilding structures. And for that, it's actually quite good. But when you actually need to run the node, the Python obviously comes with some baggage in the form of runtime performance, which the CPP version could probably reduce, or for sure can reduce.
Yeah.
Yeah, but I also have to leave. So if you have any more questions, you can write me a mail. It's at oberacker@fzi. I can maybe also, is there a chat here? No. Oh.
Yes.
You can also just put it in there. So if anybody has any other questions, you can just write me a mail or check out our GitHub repo, which I will also put in there. As I said, this is at the moment, it's still what I would describe as research code. We're actively working on making it better. But if you want to try it out or find any bugs, you can just write us an issue or something like that. We will be happy about it. And we're also trying to look at it quite frequently. So yeah. Thank you for your attention.
Your email address into the minutes, if that's okay.
Yeah.
Then people can reach out to you. Yeah, thank you very much for the presentation. Very interesting. And let's keep in touch.
Yeah. Have a nice rest of the discussion.
Thank you.
Bye.
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 Yeah. That's that. Yeah, as I said, I always was very interested in that. Happy that David found the time to present it to us. The second thing that I wanted to discuss is, I have already sent a couple of emails to the right people, but I had the idea that one of the goals of the working group was to not to be so much focused on behavior trees, but to be also looking at different technologies that exist in this field, what we call deliberation layer, which is the layer that controls the robot. And so the idea would be that we maybe could propose a ROSCon workshop. The next ROSCon will be in Odense, and to then kind of go into the workshop with a predefined set of robotic problems or robotic tasks, some simulations, some little pieces of robot code that you can execute, and then basically have in the workshop fixed slots per deliberation technology. For example, one slot hosted by Davide Faconti, one slot that's concerned maybe with FlexB, which would be a finite state machine, and so to basically solve these same problems in these different technologies. And this way, the participants in the workshop would get a hands-on experience with these different tools, and would also be able to kind of get an idea of what it takes to solve these problems in these tools. Because I feel, especially with behavior trees, it's often quite a mental load that's very different to, or feels unnatural to beginners, and stuff like that you could experience in this workshop. We could also have just one session where people just try to solve it with plain Python or C++ code, stuff like that. Yeah. This was the idea I wanted to pitch. What do you guys think?
Sounds nice. I wonder if people should actually run something, right? Because that's usually the issue in workshops. But like, even though you provide a Docker container, it's still quite challenging, and the Wi-Fi is really bad on site.
Yeah, we really need to prepare. It's all about preparation. So you need to prepare the stuff well and then tell the people what to download and to install before.
Yeah,
But it can
because
be fun.
usually you run very much out of time, especially if you want to do 6 different technologies.
Exactly. Yeah, that was also my worry a little bit, that you, on the one hand, you want to have complex problems because otherwise they are not interesting. On the other hand, you want to have simple problems because otherwise it takes forever. And that's maybe the balance to find there. Yeah.
Yeah.
And then probably also the stuff we do in Convince with the formal verification of these could also be a part as well of the workshop. Yeah. But I'm generally still looking for someone to help me. So if you're interested, would be very happy for support. I have talked a little bit to the people that would be the providers of deliberation technologies, to basically to Davide Faconti, to what's his first name, the new FlexB maintainer, and also to David from FZI, we just heard, which they seemed interested. But I think I would also be happy about support for like the general setup of setting up of these different problems and stuff like that. So yeah, if you're interested.
Pretty sure Lund would also be happy to present Skyros 2 there.
Yeah, but only if you also help with the problems. So who at Lund wants to do this, Matthias?
I don't know, we have a research engineer, or
Okay.
they by now.
Okay, cool. Yes, yeah. Sounds good. Yeah, and I think it would be also helpful if for all the technologies we have already some kind of a setup, like a kind of all the boilerplate ready, so that basically you just have to fill out the behavior tree or whatever the formalism is. Yeah. Good. But yeah, that's it from my side. If you guys have nothing else to discuss, I'm happy to close the
But
meeting.
you're pretty certain that you would file this workshop, right?
Yes.
Okay. Yeah. Because I was also thinking about filing a dedicated Skyros 2 workshop with some other people. And then this would kind of overlap.
Yeah. Yeah, so I don't know if it
But
would
like
be
it's
kind of
very early plans.
yeah, I mean it would be kind of alternative to like a separate workshop for you then, I guess, but it depends a bit. I think Skyros, for me, it always feels big enough to fill its own workshop, but I don't know.
Okay, we can talk.
Yeah, we also have some experience with making such workshops, so if some help will be needed from Krelix, then we can also maybe think about participating in it. But I need to discuss this first with the team, of course, like what problem can we bring there, and also like agree with the setup. Usually this is a big issue.
Yeah, cool. Thank you very much. Yes, I have found out about Karelix on LinkedIn actually, and I think one of you guys will present also in the next meeting. So just as a heads up, so thank you very much for agreeing to do that, because you presented I think on LinkedIn it was a task manager. It's the name, right? This, yeah, would also fit in this field of deliberation technology, at least how we define it here. So I think that's very interesting, and of course would be also happy to include this in the workshop if it works out.
Yeah, we have joined today also to take a look on how does it work and to be able to prepare ourselves for the upcoming session.
Okay, cool. Cool. Then maybe also just as a heads up for everyone, we still have this ROS enhancement proposal open. So also maybe for the people from Corelix that are new, I think. This is the idea there was that we need to standardize behavior trees a bit, and in a bit I mean a lot, with respect to how they actually work internally, because otherwise stuff like this, the translation between the different tools that we talked about with David won't work, and also our efforts in verifying the correctness of the behavior trees also won't work. So if you guys have some time, feel free to look into it, whether you have a comment or you think something could be improved. This is supposed to be a bit of a product of the working group.
I've seen something at ERF done by DLR actually, so the Deutsche Raum, so the airspace agency, so to say.
Okay.
They were presenting their robot and some state of behavioral trees behind. I'm not 100% sure if this is in ROS or not, but I know that they also contribute in open source in general, and it looked like, of course, like behavioral trees, but then but also with some AI behind, so that like one part of this behavioral tree was triggering some AI task, like with or including AI. It was trying to open the dishwashing machine, and like, okay, now the task was to get the plate out of it, but then the plate position was like not specific, of course, and then it was trying to execute this action. I have the contact of the guy there and can cross-check and maybe like connect him to you.
Okay.
Also.
Yeah. Thank you very much. Was it a workshop, or did they have a booth? Or?
Oh. Yeah, they had a booth. They had a booth.
Yeah, unfortunately I wasn't at ERF, but okay. Yeah, I mean everyone does behavior trees these days, so it's no surprise there. Okay. Cool. Then I wish you guys a nice evening and afternoon, and we speak again in early May, and we'll learn a bit about Corelix Task Manager. Okay.
That's wonderful.
Bye.
Bye.
Bye. Thank you.
Bye bye.
Thanks. Bye.